D2 back in the shop. Jay Kilroy here, ready to get a little project done here. What I've got right here is a float lock drill press vise. You might have seen, you may have one of these. You may have seen one of these in some of Tom Lipton's videos. He uses one on occasion. I think Adam also might use one on occasion, but this one here I picked up at a flea market for about 20 bucks, and it looks it. I don't know if you're familiar with how the float lock works, but basically this fixed jaw can be positioned along the shaft here, and then this movable jaw, which only has a travel of about an inch, provides the clamping force. I'll bring the camera over and show you a closer look at this, but the shaft has a groove cut in here with a bunch of little steps to engage this locking pin. Anyway, mine has seen better days. The shaft has a ton of drill marks in it, but it is still functional. I can order a replacement shaft from Float Lock, or Heinrich, I think, is the company. But this one does still function, so you know, it isn't all that pretty, but it works. So we're going to leave it alone for now. What we are going to change here is the jaw inserts. There are two jaw inserts in here. Again, I'm going to bring the camera around in a second. And the jaw inserts are just drilled all up and beat all up, and in some cases band sawed, and so they're pretty banged up. So we're going to make two new jaw inserts for this. We're going to overall just give a little cleaning and get it looking in a little better shape. And then the locking pin sometimes needs a little help to go back in, so we may have to do a little disassembly, a little cleaning here. So let me bring the camera around and show you in a little bit more detail what we're looking at here. So here's the moving jaw. Like I said, it only has a little range of motion. Might not even be an inch. It just has a slight range of motion, but that's not really an issue because this jaw can take up a fixed location. You can open it up, put your workpiece in here, and then clamp. There's a ridge in the top of the jaw here for holding a piece here, and the way these are often used is with a little clamp here on the side that would bolt into a T-slot as an anti-torque rotation element. And then you can, the reason they call it a float is because you can move it around on the table as you see fit. As you can tell, I've already done a little disassembly. We'll go ahead and finish that process here. Here's the fixed jaw, and like I said, it's pretty banged up. There's lots of cuts and notches and grooves cut in it. It's banged up pretty good. The shaft too is pretty nicked up. People have drilled into it, but it is still functional. It appears to be made out of cast iron, if I'm not incorrect. And then here's the groove that I was telling you about that has the little notches in it for the moving jaw. You can see it's been band sawed here. So pretty nasty, but functional. So anyway, we're going to make a new jaw for the moving jaw and the fixed jaw. The fixed jaw is thicker for some reason. Not sure why, but it is significantly thicker. So we we will have to look into that once we get it off of here. These babies were a booger to get off, this one right here. So let's go to the vise and get this jaw off here. Well, this one's surprisingly easy to come out. All right, there she is. You can see down in there. I believe you can see that, the locking pin. Might just be a matter of cleaning this up a little bit and getting a little lube done in there maybe. All right, done a little cleaning up. We've got the two fixed jaws off. And there's two, and the moving jaw just comes right off the end. I'm sure there's supposed to be a snap ring in there to keep it from doing so, but there's two split pins here. Split pins, roll pins, whatever you want to call them. I am guessing that one of them, good use for an apron, by the way. Boom. Pin number one. Up, pin number two. Here we go. Yep, it's going to come on out of there. There's the screw section. Ugh. There's the shaft. So the threaded portion isn't internal to the shaft, it's external to the shaft. And the split pin just registers here in this flat to keep it from coming off. So the other one registers over here, I guess, in this open section. So we'll have to do some cleaning there. Some nice schmungus up there in the interior. So now that you've got this thing completely apart, there's not a whole lot to it. Pretty straightforward. What I got to do now is get me a drawing of this jaw to start from. What I'm going to do is I'm going to create two jaws like this, one for each side, make a matching pair, instead of having one groove jaw and one flat jaw. So we're just going to make two jaws like this. Instead of making them out of steel, I'm going to make them out of aluminum. Less likely to mar my work and less likely to damage my cutting tools too. So we're going to make this out of aluminum. Just some quick dimensions. Looks like 1 3/4. Yep, almost 1 3/4. Tall, 3/8. I'm guessing. Close to 3/8. 3/8/4. So we'll just go with 3/8. No big deal. And then total length here looks like 5 inches. Yeah, 500. The hole to pass the shaft is 1 inch, and the shaft itself is a little undersized, 0.99, and the hole is a little oversized, 103, 104, so 1 inch. So we're going to retreat to the computer and do a little CAD work and draw up our replacement jaws for this float lock vise. Before we do that though, let's take a look here. One of those split pins goes through here and keeps this in the assembly, keeps the this attached to the rod. Looks like some dried grease. And there's a spring in there that I'm guessing this was supposed to do something at one time, but that's a little thrust bearing, I guess. Need something. There we go. An old spring that has been in a washer. That is I guess when you tighten the there's plenty of slop in there too. Look at that. When you tighten the handle down and the threaded rod, the threaded section passes up in here, it would press on this spring, press this washer up against this handle and allow it to maintain position. Maybe that was the idea there. This is really flared out and beat the hell up here. This is worn significantly. All right, so I did a little searching around on the web. Went to the Whalstrom website, and I will provide a link below. The Whalstrom website is the company that currently sells the float lock vise. So this does not appear to be a factory part. So the factory jaws, at least through my limited research, are both the style that were on the fixed jaw, that were moving jaws with the 2 V grooves. So this does not appear to be a factory piece. So I'm going to do the second jaw, both jaws, to match the one that is on the moving jaw here with the V grooves, not this style right here. So there we go. I've done some CAD work, so we are going to get out the drawing for the part, and I've got some aluminum sitting around here, and we are going to make these out of aluminum, not steel. And I think they'll be maybe a 1/2 inch thick instead of 3/8 of an inch thick. Not a big change, but that's how we're going to make them right there. So let's get started. All right, we're over at the shaper. We got our blanks cut out here. We're just going to face these off. I mean, I'm not really trying to remove any metal. I'm just trying to clean them up a little bit. And the machine's been warming up for a little while. You gotta do with these things. We'll be using good old-fashioned WD as the cutting lubricant of choice for WD-40 for aluminum. So we're going to get it fired up here and speed our stroke up a little bit. All right, that's 55 strokes a minute. Right. All right, we got our feed set to 20 thou. That click you hear is the feed pawl. Quite clean up there. Feed down just a little more. This is not a tool bit for serious hogging, so I'm gonna speed the feed up to 40 thou. That's a 4 thou cut right there. Little razor blades. Well, almost. This is a tooth-out cut here. All right. There's the chips. They're very light and springy. We got a very nice finish here, very smooth. Even though you can see the pattern of the tool, you can't feel it with your fingernail, so it's a nice smooth finish. Oh, a parallel fell. Turn over here. Stick with what works. With this type of tool bit, the way this thing gauges the work, basically the harder I feed it, the longer the area of cut. All right. I need to stop getting so manly on that vise. Here's our as extruded finish. Here's our deluxe shaper finish. Check that out. Beautifully smooth finish. Looks almost ground. Let's knock the other one out. Do it. Let's increase the feed to 50. can see how the chip is wider. Excellent. I just increased the stroke length a little bit, give me a little more clearance off the end of the part. That also increases our surface speed just a little bit because the number of strokes per minute remains constant. All right. I know you guys and gals always like a little deluxe shaper action. So let me dry that off just a second. little bit. So this is the 40 thou pier feed. This is the 50 thou. You still can't feel that line with your nail. It's still not really perceptible. But that's a nice finish. I can go with that. All right. Got my drawing here. Better drawings make better parts. I got my part in the vise. Big features first. We're going to do the big hole. We got it lined up this back corner with the corner of the vise, which is always my 0, 0. So we're going to come out 875 this way. Oop. Blew right past it. There we go. There we go, 875, put a lock on. And then we're going to come down another 875. There we go. Put a lock on there. Make sure I'm not going to cut my parallels. I shouldn't. All right. Where's my WD? Again, for cutting aluminum, WD-40 is your friend. Let's just slow it down. We'll stay in. Well, that was easy. That was 500 RPM, straight in with a 1-inch bit. And I hate using black oxide bits and aluminum because you get that silver buildup in there. That aluminum buildup, which is problematic. So let's go ahead and we'll swap parts, and then I will come back for the next operation.